So Quentin, you on the call first. So you've got first option on what to cover. And it's 11 o'clock for you. So I want to cover what you want to cover and then move on from there. You were the one that asked about filtering of data, was it?
Yes, Frans. So I want to filter my borel data.
Yeah.
And I want to filter with the meshes, the closed meshes.
All right. Now to cover to cover that aspect, I'll have to go through some of the items on my list because that's an involved topic. So I'll start on that one. That's fine. So before I start, I'm just for those ones that's not well known about this, I'm going to refer to some things as I go through my talk. If I refer to the ribbon, then it's that section on top. So that's the ribbon. That includes the menu on top. That's all part of the ribbon. So that's the first component. That's the most important one. Then I'll talk about a top toolbar. I can talk about the left toolbar, and I can talk about some of the other toolbars coming up. But that's the toolbar. So the toolbars are the one that's just outside the scene area. Now this is the scene area. So if I load anything, any data I load, that will go into the scene area. So the toolbars are just outside the scene area. And then you've got panels. So you've got your left panel. So that's the one that's got the meshes, the markers, the mapping, and so on. And then you've got a bottom panel, and you've got the right panel. And on the right panel, you find things like move and rotate and scale and transform and so on. So when I refer to some aspects, that's the logic that I'll be following. So when I refer to a specific button, I would, for example, say ribbon, and then I would say drill hole. So you just go to drill holes. And then you see at the bottom, there's that it's divided into boxes. And the first box name is scholars. The second box name is survey. And the next box is GEOTech lines and so on. So if I refer to something in the GEOTech lines, I'll say GEOTech lines. I would say, let's say, for example, create GEOTech. And that would be the button that I refer to. So I think that's quite easy. Can I ask, if you're not asking an active question at that point, to just maybe put your phone on mute? Thank you. I know it happens that you by accident forget. I forget as well. So it's not a train smash, but don't take exception if I ask you. Thank you. So I think that part's easy. So when you've got something loaded in your scene, just quick. So your mouse buttons would be left. You would, if you take the right mouse button, you press it in, you move it up and down. That zoom. The middle mouse button, that would be panning, and the left mouse button would be rotation. And that's quite intuitive. The ones that's not intuitive that people should know about and that you should use often is double click. So if you want to change your rotation point to a specific location, you take your mouse cursor to that location and you double click. And if you then double click, that becomes the rotation point of where you're looking at. You'll also see when you double click, there's some data coming up in this text box at the bottom right. And that text box gives you some information about what you're clicking on. So if I double click on a new location, that new location coordinates will be coming up there. There's also other changes that are happening. You'll see as I double click in this clipping box, the elevation will change as I double click on different locations as well. So it changes the rotation point, but it changes some other aspects in the program as well. So I think that's fine. The next thing I just quickly want to talk about, because we need this, especially when you want to do the filtering, Quentin, is something called parallel view and perspective view. And I think the best way to do this, I'm going to take this piece of data I've got in my scene, and I'm just going to create a bounding box. So I'll go to mesh, and I'll say, I think it's down to, where did I put it? Other fact, where did I put it? Save TXF other. So if you go to the ribbon, you go to mesh, you go to save TXF other, you can create something called a bounding box. So I'm going to create a bounding box. I'm going to call it BB for bounding box. It's not loading it, it's just creating a bounding box. So then I'll go to mesh, load and import formats, add TXF, and I'll load that file that I just created. And you'll see what this does. It creates a box. Now the colors are unfortunate, it's just a random color it's selecting. I'll just change the color to something else. So it's just creating a box that encapsulates the object that you've got on your scene. And that box that's now created, it's sometimes very useful. It consists of two objects. It consists of the mesh object, so that's this one, the orange one, and it consists of the purple one in this case, which is now the outside boundary box edges. So it's just the edges of the boundary box. So sometimes these boxes are useful to extract data because you can use it like any other wireframe, and then you can extract data within or without or so on in these bounding boxes. So this is now the bounding box, and there was a reason for this. Oh yeah, I'm going to use the bounding box to explain perspective versus parallel views. So if you look at the box as is at the moment on the scene, you will see that it moves to the back and it gets smaller. So stuff further away from you becomes smaller, as you would expect like in normal life. The further something's away from you, the smaller it becomes. So the way you achieve that in software is there's what they call a vanishing point at the back. So you can see if you extend this line all the way to the back and you extend this line all the way to the back, they would meet at some point at the back, and that would be called the vanishing point. So this is perspective view. Now what's bad about perspective view, if I make a selection within a perspective view environment, because that access into the scene is forever changing in scope, as you go back it gets smaller. There's no one way of make a selection that would that would that would be very precise in the way you select your selection. So the moment you do selections, I'm actually always going to force you, or the software is going to force you to go into something called parallel view. Now you'll see at the bottom, at the top of the ribbon, there's a parallel view checkbox. So let's have a look at the scene, and I'm going to check the checkbox and see how it changes. So if I now press the parallel view box, you can see it looks quite different from the original view, because in the parallel view, meaning these lines doesn't go to a vanishing point. They always parallel to one another. So this line, if you continue all the way to infinity, and this line, if you go all the way to infinity, will never meet one another. They parallel. So when you're in this environment, that's ideal for doing any type of filtering or selection, because there's only one depth. There's no ambiguity about what the meaning of a selection means. Can I ask if there's any questions about the interface, the mouse control, and this perspective view concept? Is that all clear?
All clear, thanks, Frans.
Okay, cool. The next thing that's important when you work with boxes, and I'm going to use the same one, I'm going to use this one to explain this, because this is sometimes quite difficult to understand. So I'm gonna take away all the other objects. The only object now remaining is this box that we're working with. If you go to mesh, if you go to the ribbon, if you go to mesh, and you go all the way to the general settings, there's one checkbox that says backface culling. Now, if you check the backface culling box, so I now check, and nothing changes within your scene, that means that all the polygons are actually looking to your side. So before I maybe explain this, I just have to say a polygon, like any of these polygons, only have one side that's visible. But in software, and that's all of the software, I'm doing it, Datamine's doing it, Daysmix doing it, Leapfrog's doing it, they would always show a polygon as two-sided. But it's just a visual trick. It's not reality. In your scene, in the software, every polygon has one visible side, and the other side of that polygon is actually invisible. It's not visible, and I'll show it shortly with another example that's maybe even clearer. So given that fact, so if I take this and I say backface culling on, nothing happens. It means all the faces, all the polygons are showing in my direction. So I see their visible sides. But now I'm going to press the button just below that says flip polynormals. And you'll see, now you have to be careful, because this is something that sometimes is a bit difficult for the brain to accept. So if I press it, you'll see there's now a change to what it used to be. If I flip it back, it's back to what it used to be. If I flip it again, what you're now looking at is the inside of the box. So instead of looking, so the front face, the front polygon is still there, but you're looking through the front polygon and you don't see it, because this side that's now looking towards you is now invisible. And the same with the top one. But the bottom one that's on the inside, you can now actually see, and also the sides and the back wall of that box. So now what you're basically looking at is the inside of a box. So this backface culling is really, really important when you start filtering data according to polygons or meshes. And we'll get to that component. I'm not going to, I'll get to that. I just want to finalize this one aspect. So I'll use another example to show this. I think this one is maybe a bit easier to grasp for those that maybe could be struggling. I'm just going to load a pit shell. So if I load a pit shell, let's change the color to green or something else. So if you have a pit shell and I say backface culling on, and you can see the pit shell basically vanishes when I say backface culling on. And the reason is all these polygons are showing to the inside or to the bottom. So you can see it from the bottom, but you can't really see it from the top. So if I now swap or flip the polygon normals, now it's the opposite. I can see it from the top, but I can't see it from the bottom. Now, where this becomes, so when you get data from Leapfrog, Leapfrog is actually really good at always giving you the right side of the polygon. And you'll see when you use Leapfrog, they use two different colors for the front and the back of the polygon. But if you use packages like Desvik and most of the Mind Design packages, let's just load a file as an example. Which one will work? Maybe Lantern. Then you'll see these guys are unfortunately not as clean on their data sets. So if I now say backface culling on, you can see some of the stope. So if I just zoom in on this particular one, so if you look at this stope, then you'll see that this one doesn't change, but the ones adjacent to it does change, which makes it a bit difficult. So if I now say backface culling on, you can see this one didn't change. So all those faces are looking towards the outside, but you can see these ones actually did change. So they're looking in a different direction. And that thing has to be cleaned up. And sometimes it's even messier than this one. So I'll load another example because I think the next one I'll load will indicate what I want to show. Lantern. Let's see if this one shows it. Because, no, it doesn't. So what you sometimes find is you'll find some of these shapes, the one polygon on the same face or the same surface will look to the outside and the adjacent polygon will look to the inside. And that becomes a bit of a mess to fix. And that's why I've got different options in my filtering to manage all these potential options. Can I just ask, because it's important, I can't really move on if there's inside and outside of polygons, if that's not clear. Everyone's happy with that? Okay.
Yes, thanks.
Cool. Can I just ask, before I then continue, can I directly move on to markers? Or should I go through the process of creating the markers, doing the drill hole process? Quentin, I'll ask you.
I'm quite familiar with the drill hole process, Frans. So if some of the other guys want to see it, it's fine.
Okay, can I ask if anyone wants me to go through the drill hole process, please let me know. Then I'll do it because it makes logical sense to cover it now. If you're not speaking up, then I'm just going to move to markers and then go from there. Okay, so it seems like everyone is familiar with markers, with drill holes. So I'll just use markers. So for this example, I'm going to use a different examples data set just to make it a bit easier. Yeah, it's just a quicker data set because filtering could sometimes take a while. Let's start with this data set. Okay, so let's see if we've got data like this. So this is coming from Leapfrog, so I'll start easy. So this is quite a complex data set, but you can see what's nice about this data set is each one of these objects have a separate, or each one of these shapes is a different object. So you can go through and you can activate just this some of the objects, or you can activate all of it. So let's see how clean this data is. It's coming from Leapfrog, so it should be good. So if I go to backface culling, and I always do the backface culling check before I filter. If I go to backface culling, you'll see if I check it on and off, there's no change. So this data set is perfect. And because it's perfect, I can use this data set in a different manner than when you've got a data set that's not perfect. So let's just first go through the data set that's perfect, which makes it far easier. So this data set, perfect. in which case I can use some functions that otherwise I can't. So I'm going to load some marker data that goes with this particular data set. So I'm loading some drill hole data. Although this is not drill holes, it looks like when it's obviously coming from drill holes, it's composites from drill holes. But if I zoom in close enough, you'll see these are all points. It's not lines, it's points. So it's data that was composited from normal drill holes. Let's just use the appropriate data. Let's look at the RQD, for example. And the RQD goes from 0 to 100, and you can see normally we're typically quite bad RQD. So in this particular case, let's say you want to extract all the data within the meshes. Now, this is not a trivial process to do because there's so many meshes about. So you go to markers, you go to the ribbon, you go to marker filters, you go to manual, you say relative to meshes, and you can use this simplified box because the meshes are good. If the meshes were not good, you can go to the third option, which then expands this box to more options. And we'll get to that one. I just want to mention it for this at this point. So at this point, because the meshes are perfect, I can just go for number 1 or number 2, and I can say, okay, let's keep the data inside the closed meshes. And because the meshes are perfect, that's all I need to do. If I say accept, it should now go and it will extract. It will do a test for every point to see if it's inside a mesh or outside the mesh. And based on that choice, it will now give you the data that you want. Okay, so there's your data set that's specific to inside the meshes. So I think that's quite clear. So the one question Quentin had was, let's say I want to give this data a different property to other data. So I'm going to say reset all. So I'm going to reset my meshes. So, and I'm just going to expand this box somewhat. I'm going to right click and I'm going to say, let's add a blank grid column. So I'm going to add a blank grid column. And I'm giving everything within this column. I'm going to give it a UCS value. I'm going to say, typically this rock mass is 50 MPa, just a number. Sorry, that's not what I wanted to do. That's when you talk. I'm just going to load the data set again because what I've now done is I added 50 columns. That's not what I wanted to do. So I'm just going to load the data set again so I can fix my mistake. So you say add grid columns, and I'm going to say I just want to add 1 column or 2 columns. I'm just going to add 1 column. Okay, now I've got a new column that I can manipulate. I'm going to go to the first number and I'm going to say 50. So let's assume this is representing my UCS data. So I'm going to say, okay, make it 50. Then I'm going to right click in the box and I'm going to say copy to visible column cells. So what this will do, it will copy that 50 across to all the other rows within that column. So let's do that. Okay, so what I've done now, if I look at column number 5, they should all be the same color because they all have the same value. So if I now look at, so if I make them or these guys all transparent, they should all look the same. Okay, so now what I next want to do is I want to do what I did in the past. I want to extract the data within the meshes. So let's do that. Markers, ribbon, marker filters, manual, relative to mesh, and keep data inside closed meshes, accept. So now I'm going to end up with only the data within the wireframes. So only those will be visible. And because it's a filtering process, those are visible and it will be the only ones visible in my grid as well. So let's say within those wireframes, the UCS is 100. So I'm going to make the first 100, right click and say copy to visible column cells. So I'm going to copy it across to all the visible column cells. So all the polygons or all the points inside the markers is now one value, and all the markers outside that mesh is another value. So if I now reset my data set, and I'm just going to hide the meshes for a moment, then you'll see you've got 2 separate colors. And this is the 50s and that's the 100s from the selection. Is this part of what you wanted, Quentin?
It's almost part of it, Franz. Let's say each of those blocks, those different colored blocks,
Yeah.
have different UCSs or that
Yes.
object name. You can't take that object name and save that as a column. Uh, each marker point that's in a different mesh.
I see. I see what you want to do. I can
Yes,
actually. That's not at the moment available in the software, but that's actually a good suggestion. So so when you do this type of extraction, it will actually tell you which block it's coming from. Yes, that's
yes,
easy. That's actually quite easy to do, and it's quite a it's a good approach. So then it will just be another column to that adds to the backside of this that
yep,
says the object that marker point was part of.
yes. Because I think you're
Very
already doing it. It's just not capturing it.
well. It's not that. Yeah, it will be a bit of coding, but it's not difficult to do. I've done something similar a while ago. What Kobus Deploy was asking me is I'm just going to load some different data set just so you know about this because you could maybe use it. So let's say I load something like it's something I loaded before. So let's say lantern. So let's say I load each one of these. Now each one of these stopes is a separate object. You can see there's a whole bunch of objects. They're just all the same color. There's a whole bunch of objects. So one of the things that people sometimes want to do is they want to have the center point of every object saved out separately as a point, because then you can say, well, that point, which is now the center point of my stope, represents a lot of properties for that stope. And you can give it hydraulic radius and risk models and a whole bunch of stuff to it. So what you then do, so you take this, you say mesh, you say save, not I'm lying, export, you go to the ribbon, you go export files, and you say, I want to save the mesh info as a CSV file. So you go there and you'll see there's a whole bunch of options. And as you keep your mouse on it, it gives you a bit of a short tooltip to explain what it means. So in this case, you want to do the individual object centers. So if I say individual object centers, and I'll just give it a name. I'll call it ZZZ. So if I now load that file that I just created as a marker file, ZZZ, and I take the meshes away. So now you've got a point. Let's maybe use a different background. So now you've got a point for each one of those objects. And if you open up that file that I just created, let me open up the file. Uh, I'm just off the screen for you at the moment. I'm just opening up that file that was created, and I'm just opening it as an Excel file. So initially what this did, it only gave you the XYZ, but I added the option to also add the object name to it. So what you're asking me is just adding that same column to the other function, to the function we just discussed. And that's easy enough. I'll do that.
No, thanks, Franz.
That's perfect. That's a good question. That's a good suggestion. Thank you. Okay, so let's say you've got a messier data set. So you've got a data set that's not as clean. How do you go about the process then? So let's maybe go back to the normal one. So for this one, I'm going to use a different data set. So let's load something simple like this one. And I'm going to load just a few drill holes. Let's see. I think I've done this before. So RQDs. Or maybe it's going to be too many. Maybe it's going to be a lot, which is fine because then I can show and explain a few other concepts as well. So I'm loading the data set now. It's a marker data set, but it's a big data set. So it's going to take a while, unfortunately. Sorry. I haven't thought this through well enough. I'm just thinking if there's a way I've got less data. Let's have a look. And I can drill holes. Okay, I think, yeah, no, this is going to take too long when I start filtering it out. So when this file has loaded, I'm going to load a different file to it. This is going to take too long. This is one of the most comprehensive data sets I've got. So you can see this is a very comprehensive data set. I'm not going to use that one. So I'm just going to go to a different location. Marker, text, this one. And I'll go to drills, and I'll go to geotech lines and geotech composites. Come on, that's not what I thought I'll do. I did. Oh, that's why. I went to the wrong box. Drills, collars, composites. Okay, there's only a few holes now. So let's just load maybe another mesh because these meshes aren't coinciding with the data set as well as I hoped for. So let's go for maybe the lantern stopes. Let's see if those ones doesn't do too well as well. So I'll try the lantern stope. That should do it. Anyway, it doesn't match well, but it's fine. So I'm still going to use this. So if you look at this data set, I'll just zoom into one of the steps and I do the normal test for backface culling. You can see the backface culling, unfortunately, is not very well done. So it's inside some and it's outside some other ones. So when you've got the data set that's not clean like this one, you unfortunately can't go about the normal filtering process. And you can't just say you still go to relative to meshes, but you can't use the first two options. Then you have to go to the extended options. And I'm just going to explain the logic of my extended options. I'm not saying that's the best way to do it, but that's the best way I could figure out to do it. So the way you read this is as follows. So I'm going to say mesh in search direction has to be shown. So I'm going to say, so if I satisfy my setup, it's going to show the data. It's not going to hide the data. It's going to show the data. If the distance is -1, the distance is ignored. It's not taking account. It's going to infinity. Conceptually, it goes to infinity. So when the data distance is not specified, it goes to infinity. If you specify a distance, it will only extract the data in your search direction for the specified distance. So that's when you say, I want to look at all the data, let's say 20 meters into the hanging wall of Stokes or something like that. So I'm going to keep it as -1. I'm going to search up. So what it's saying at the moment, what it's saying is when I search up and I find the mesh intersection, I find the mesh above me. It doesn't matter which side of the mesh it is. If you find the mesh above me, if I search into infinity, it will show the data. Does it make sense? You can also say I want to search down, north, east, south, west, or you can custom specify that search direction. So you can say, if I search, and now you have to be careful because the way we use dip is different to the way geology uses dip. So in geotech, don't ask me why, but the convention is different to geology. So if you stretch your arms out horizontal to the floor, then that is zero dip for both us and geology, no difference. But if you then let your arms go towards the floor, your hands towards the floor, so you go downwards, for geotech, that's positive. But for geology, that is negative. So you have to be careful with when you select your dip that you do it in the geotechnical fashion, which is positive as you drop your hands towards the floor, if that makes sense. Then you can extend it a bit more. You can say, I want to search up. And you can see there's a box that says search to both directions or both sides. So what I now say is I'm going to search up and I'm going to search to both sides, the opposite side, so it's down. So I'm going to search up and down. And if I hit a mesh, I'll stay. And if I don't hit the mesh, I'm gone. Or you can say or, which means I'm going to search up, I'm going to search down, and if any one of these two intersect the mesh, then I'll stay. Sorry, so I just have to clarify. So when you say and, you have to search up and down and find the mesh in both cases, and then it stays. The other one is or, so I search up, I find a mesh, I stay. I search down, if I find a mesh, I stay. And I search up, and I find a mesh, then I first have to search down as well. If I again find a mesh, I'll stay. And if I don't find a mesh going down, then I'm gone as well, because it has to satisfy both criteria, and up and down. So obviously, if you say up, then if you take this box, then the opposite is down. If you say north, then the opposite would be south. And if you say east, the opposite would be west. And if you take your custom direction, the opposite would be 180 degrees from that option that you have selected. Okay, so now this is not intuitive, fully intuitive. Can I ask if this is clear enough for most people to grasp? do I have to extend that a bit further, or are you happy for me to leave that explanation? I think when you start playing with your data, it will become clear on what the meaning of those boxes are. Just know the first two is available if your meshes are perfect in terms of their orientation. The moment they're not perfect in terms of orientation, then you have to go the complex route. Cool. Quentin, so have I answered all your questions?
Yes, Frans, thanks.
Cool. May I ask anyone else in the call, is there another question that you want me to look into? Jeff, nothing's particular on your side?
From my side, you showed a number of those wireframes which you get out of lovely Leapfrog or other projects. I've got a lot of these files which are coming through very large. Is there a simple way to be able just to reduce them from tens of megabytes to if you like single megabytes? Rather than 100, be working on something which is more like 10.
There's a way. Well, there's a way that you could do it for some. It's not going to work for all cases, but I'll show you. Yep. Okay. Thank you. Can I just ask, Jeff, is it open pits or is it undergrounds or both?
You can do open pit for now, and I'll apply it to my underground.
Oh, open pit is actually the easy one. so that suits me exceptionally well. But I'll also cover the underground because I think that I use it quite frequently. So yes, I'll go through both. So let's start with open pits. Thank you, Jeff. So I'm going to load an open pit, and so let's say I'm just going to load the file that I've got. So let's say that's your file, and let's say that's a humongous file. It's way too big. You can't manage it. This is not, but just for our example, how would you go about simplifying that file? So I'm going to go through some processes and fail, but I'm failing on purpose because it gives you some understanding of what I'm attempting to do. So let's go for this one at first. So there's different ways in simplifying a mesh, and obviously the most obvious ones is to reduce the polygon count, one of those two. And you can do both, and you can see how good or bad it is. And typically for this scenario, it's not going to work very well. And what it's going to, if you decide to use it, because they actually work well in some scenarios, if you decide to use it, it's going to ask you for the number of iterations. So what it means is internally, if you say 5 iterations, it will take that algorithm for simplification, run it 5 times, and then give you an output. So if you say 5 or you say 50, the output would look very different from those two functions. So just be careful on your number of iterations. I'm not going to do it because it's not going to work well for this particular scenario. The one that I'll be using is this surface Delaunay 2D. So Delaunay, I'm not saying the name to confuse people. I'm just saying the name to say that's the algorithm I'm using to create a surface onto something else. So create a Delaunay surface. So I want to create a Delaunay surface, but when I do the Delaunays, that's the 2D and the 3D Delaunays, I'll cover both just to show you the differences. You'll see there's also a toggle button involved, and that toggle button is really important. So if the toggle button is on, which is the default, it means it will take everything on the scene, it will create one object from it, and then it will drape one surface on all those objects. And that normally works well for open pits. But in underground, that's normally not working well. So for underground, what you normally would do is you will untick that toggle, and that what it will then do, it will take every object, and I'm going to do it soon in my next example. It's going to take every object and drape a surface on every object separately. So it's going to be separate objects that it's going to drape surfaces on. And it gives you a very different outcome. So for this example, because there's one object, it doesn't really make a difference. But because it's open pit, I'll tick it on, because then it will take every object in the scene and it will drape a surface on all those. Well, it uses the points when it drapes these surfaces on. So let's see how it comes out. So I'm going to say yes, drape a Delaunay surface. It's going to ask me a tolerance. Now, the smaller this number is, so that's the default tolerance, the smaller the number is, the more finely divided this surface is going to be on that new surface. So I'm going to just make extremes. So I'm going to say 0.1. I'm going to say, okay, it's asking me, do you want to drape it directly vertically down, or do you want me to fit the planes through this object and then drape it in the direction of that of the normal of that plane? Because you just want to do a surface, in this case, you would definitely want to say, no, drape it down vertically. So the option that you select is yes. And let's call this XXX course. I'll just see for course. And you can see what you now created is a very simplified version of the original pitch shell. It's still the pitch shell, but it's just a really, really simplified version of that pitch shell. Okay. So now you've got a very simple simplification. So let's kill that one because that's not useful for our purposes. So the next one I'll do is I'll say, okay, so let's use the default value. Now it will take a bit longer. So it's going to be XXX for, let's say, default value. Now it will take a bit longer because it takes a bit more detail. But you'll see this is now a vast simplification. So if you look, well, it's vast simplification, not if you look at the sizes of the wireframes. The original one is 15. This one is still quite a bigger number. So in this case, you didn't win much. But what you'll find when you do this is some of these places are very coarse. So it's not as clean. The original one is quite clean, and this one is far less clean. Now, when you've got a big wireframe, you should have less of those issues because you've got more points to work from. So this is just a simplification issue when you do the draping, because what the draping sees is only the vertices of the polygon. So when this happens, you can do multiple things. You can either, well, if you've got a file that's too big, then normally you've got sufficient points, so you don't have to do what I'm now going to do. You can increase the number of points to get a better resolution for this. So how can you increase the number of points? Well, there's different ways to do it. If you work with a polygon, you can go for this function that I use a lot, where you say subdivide lines and polys split by size. So if you say, I'm not going to do it, it will take too long on this file. So let me just take a smaller one. It's just a smaller data set to work with. Let's take this one. And the reason I'm doing it, because otherwise it's just going to take too long. So if you see, so at the moment you can see this is quite a coarse grid. So if I now say, okay, I want to subdivide each one of those polygons. So let's say I select the numbers such as 20. So it doesn't take too long. What it will do, it will go through each one of these polygons, and it will look at the polygon's longest length. And if the length is longer than the value I specified, the 20, it will subdivide it to make it smaller. So if you compare the first one with the second one, so you can see that's the original data set. So let's say, so you can see each one of these benches only at one mesh height, and the new one, they subdivided now into two. So you split it into more points. And because you've got more vertices now, you'll get a cleaner outcome from this process. What often happens as well is what people are getting is just lines instead of the mesh. So I'm just going to go through that process too, because lots of people ask me about this. So I'm just going to create lines. I'm going to use a function just to create lines to work with the lines. So the function is extract the mesh boundary and edges. So yep, so I select that one. Say yes to extract the boundaries and edges, and no to extract the mesh boundary only. So I say yes, I want to have both. It's going to ask me for an angle. So the default value is 30. So it means if there's a 30-degree difference between the one polygon and the adjacent polygon, it will mark it as an edge. And if that value is a different, if it's bigger, it's going to do one thing. If it's smaller, it's going to do another. So let's take a small value just to show you what it gives you. I'm going to say 10, which is a very small value. And I'm going to call this one XXX. Let's call it XXX10. And what you'll get is this type of profile. So you see what it did, it extracted the edges from that polygon, but this is not a very clean thing to work with. So I'll do it again. So I'll go back to the original data set. I'm going to do the process again. I'm going to say extract mesh boundary and edges. Yes. This time I'm not going to say 10, or I'm going to say, previously I said 10. Now I'm going to say 60, just to show the difference, a clear difference between the two. So I call this one XXX 60. And I say now I get only a few of these points because there's not many of these polygons that's got an angle bigger than 60 degrees between them. So none of these are actually giving me exactly what I wanted. So let's take the default value, see what that gives us. So extract lines, mesh boundary and edges. Yes, I'll take the default value and I'll call that XXX30 because that's the angle. And now you can see you get a really clean outline of your surface or from your mesh. So that's a way to take a mesh and create lines from it. But let's now assume, so I'm going to delete all these other files. Let's assume this is the data set that you received, and now someone is asking of you, or you want to create a wireframe from those lines. So what I normally do first is if you go in the mesh in the ribbon, there's under general settings, there's a line vertices option. So if you check the line vertices, it will show you how many vertices that you have. And you can see your vertices are not always well spaced. They're sometimes far apart, sometimes close apart. So I want to make that more uniform. So I'll go for a process that says split the lines into fixed lengths. So yes, I want to split them into fixed lengths. I want to create myself a point and you decide the number in terms of what your resolution should be. I want to do it every 5 meters. This is a stiffness number. So when you do that extrapolation of the line, it's going to use something called splines. And a spline is a bendy thing. But if you make it a spline of 10, it's actually a very stiff spline. It's basically a straight line. So I'm going to use the default. And I'm going to call this let's call it YYY. And you can see the difference from the previous one. So the original one, so let's take this one away. Not the original one, that's definitely not it. So the original one looked like this. And the new one, the latest one, looks like, I'll just take these ones out because they're not good for us. And this one looks a bit different to the original one. Oh, that was the lines. So if you now drape a surface on the original one, so that's the points of the original one. So let's just type a default surface on the original one. So I'm just going to drape a surface. Let's call this AAA1. So that's quite messy. You can see there's a whole bunch of these irregularities on your mesh. So let's use the second one. Type same, yes. And I'll call it AAA2. And now you see you get a far cleaner surface to what you had on the original one. So this is very, very close to the original data set that you had. There's some things that messed up, like this one, this portion over there, but the majority of the surface is actually quite good. There's some mistakes. You can then subdivide it even further if you want to have a more accurate result. But I think the idea is clear. Jeff, did I answer your question or not yet fully?
That was good, thanks.
Yeah, okay, so you're happy with that. Cool. So how do you do something similar for underground? I'm just going to see if I've got a good example to use. The process I'm going to use works for any, let's say, map 3D building. Let's say this one. All right, so let's go. So this is just elementary. Yeah, this is shapes. So let's say you've got something like this data set, and you want to build a map 3D model from this. So this process will work if you want to build a map 3D model quickly. That will work for that. It will also work for what Jeff was asking for. If you've got, let's say these were very complex CMSs, how do you simplify those CMSs so you can have a far smaller data set to work for? Because sometimes when you load a big underground mine, some of those files become so ridiculously large and there's so much duplication that it's basically unusable. So sometimes you want to cut down the complexity significantly from CMSs. And this process is one way that you could potentially do that. So let's see as this data set as an example. How do you build a quick map 3D data? How do you get this quickly into a map 3D format, or if you want to simplify complex meshes? So I'm just going to do the test, and you see if I do the backface culling test, this is a very messy surface. So you can see some polygons. If you just take one of the stopes, some polygons are showing towards you and some are showing away from you. So there's no way to take this data into Map3D at this point, because Map3D expects data to be very uniform, all the meshes and polygons showing outwards, away from the excavations and so forth. So these ones you can't use as is, although it seems like it's simple enough that you should just be able to bring it into Map3D, you cannot. Also, it's just one object. So Map3D won't be happy with it. So the way you go, the process I'm now going to show it's seemingly involving, but if you get it, it's really quick to do. So what I'll do is I find out what's the difference by interlevel spacing. So I'm going to this measuring tool. I'm just going to do a single measurement. I'm going to go and I'm going to push Control in so I can reposition myself. And I'm going to go to the top of that surface to the top of that surface. And I want to know the vertical distance. So the vertical distance is 25.71. I'm just going to check it in another location to see if it's similar. So Control again, so I can move myself about. So I'm going to go to this location. What's the difference between those 2 points? And it is 24.65. So it seems like the interlevel spacing is about 25 meters. I'm going to assume it's 25 meters. So I'm going to go to the center point of any one of these stopes. So I'm going to double click, because when I double click on that center point, then my clipping will automatically go to the correct elevation as well. I want to do a lines clipping. So if I now do a clipping, I've got a clipping on that elevation. But I don't just have one clipping. I want to clip through all of these objects. So I'm going to do 101 of them, not 100, 101. I'll explain that just in a moment. So now I've got a center clipping through each one of these steps. So why did I choose 101 and not 100? You have to choose an odd number to get exactly the elevation that you selected. If you say 1, you get exactly that selected elevation. If you say 3, you get that elevation, and you get the offset distance up and down from that elevation. And I should have done that, and I haven't. So that's it. Sorry, I missed the step. I should have said the step distance is 25, because that's the interlevel spacing. Sorry. So before I did the clipping, I should have set that as 25. So that will mean you get a cut, like a slice, every 25 meters, which would be the center of every stoping level. All right, so that looks a bit better. Sorry about that. So now I'm off my story a bit. Well, yeah. So if you go for an odd number, you always get the elevation that you selected. If you go for an even number, you actually get half that offset above and below the point that you selected, and not exactly the point that you selected. So always go for an odd number. Okay, so I've created my sections. So what I then do, I just save it out as a CSV file. So if I now save it out, I'll call it XXX1. If I now save it out, because at the moment this is still wireframes, the reason I see lines is because I do a line clipping. So if I say exit, then I get back to my meshes. So what I'm going to do now is I'm going to load those lines and remove the meshes. I'm just going to work with these lines that I created. And these are now real lines. It's not a clipping line, it's an actual line. So now you can see there's a bit of a mess in this. The first thing you would like to do is you would like to break this up into separate objects. So let's see if we can break this up into separate objects. And there's a function for that which says, let me just have a look. You say, which one is it? Combine objects, combine connected triangles and lines. So combine connected triangles and lines. So if I select that option, now it's going to take a while. So what it's going to do, it's going to go through the whole process of all those lines and see which ones of them are connected. So let's see what happens. So what you then have, you can remember we only had one object at the start. So now we've got multiple objects. So each one of these objects are now separated out as a separate object. I can maybe make my lines a bit thicker just to show. And there's also a new option where you can say Series 3D. It gives you a bit of a 3D approach. If you can look at the light lines, it makes a bit more 3D-like. Although it's a line, it looks a bit more 3D-like. If you do the Series 3D, so I'll make it a bit smaller. Okay, so now you've got separate objects for each one of these lines, which is great. So initially what I had was only one object for all of these stopes. Now it's actually broken up into different stopes. But you can see if you look at every one of these stopes, there's a lot of these internal lines that's going to complicate the creation of something a lot. So I want to create a single outline for each one of these stopes. So the way I do it is I go back to what Jeff and I used before. Let's save this just so if I make a mistake, so I'm going to save this. I'm going to call this XXX3. Just so I have something to go back on if I make a mistake. Okay, so let's load. I'm going to load XXX3. I could have used the data set that I had on, but I'm going to load the data set that I just created. All right, so the next step I want to do is I want to get rid of all these internal lines. The way I'm going to do this is I'm going to use again the Lonely 2D option that I used with Jeff. The only difference now is I'm gonna make the toggle go away, so I'm gonna uncheck the toggle. What now will happen if I now say create the Lonely surface, it's gonna create a surface for every object. So I'm gonna say create a surface. I'm just gonna take the default. I'm gonna say yes because I can drive down vertically because this is horizontal slices that I took, and I'll call this XXX4. Okay, so now what I've got is I've got surfaces going through each one of those points, and I've got a single surface for every stope. Well, in some cases where they broke it up like this, you've got two stopes adjacent to one another, but that's fine. Okay, so I'm going to delete that XXX3 now. I'm not going to use that anymore. I'm only going to use these surfaces now. So now I'm going to go and use something I used before. I'm going to extract the mesh boundaries and edges. Okay. I don't want to extract, I actually just want to extract the boundary of each one of those objects. So I'm going to say no to just extract the mesh boundary. So let's see what that could give us. I'm going to call it XXX5. So what I now should have is an outline for every stope. And all those internal lines is now gone. So all those internal lines are now gone. I only have an outline for every stope, it's got a single outline. So let's look at the line vertices. And you can see the line vertices are reasonably well distributed, but I can improve on this even further. So I can force my points to be equal distance apart because Map2D will like that far more. So I say split lines into fixed lengths. And I'm going to do it. I can't select a number that's too large because if the number is too large, some of these stope shapes will change. So 5, I think is fine. I'm going to keep it a stiff spline. So I select it, I choose the 10 number and I say XXX6. And you'll see what now happen is every one of these blocks is going to have points that's an equal distance apart from one another. But some of the stope shapes has slightly changed. So if you don't like the change in the stope shapes, what you'll have to do, let's just go back to the previous file, is let's hide this one for the moment. And then just unhide the previous one. So because you lose some of the definition, you can actually decide to make that size, the distance between the points, to make it smaller. I haven't done it, so I just use a reasonably coarse value, and I'm going to continue using it. Otherwise, it's going to slow down the process. And I just want to show a concept. So now I've got an outline for every stope. I've got my points well equally spaced, so Map2D should like it. The next thing I want to do is I now want to extrude that surface to create like a tube, to create a full stope volume. For that, I need to know what is the dip angle of this ore body. So I should have met that. Let's load the mesh and get the dip angle from the mesh. I think that's going to be the best. So I'm just going to load back the meshes just for a moment, just to get the dip angle. So you can do a few tests. I'm not going to go through too much detail. I'm just going to do a single measurement, and whatever the value is, I'm going to choose. So it's going to say it's a dip angle of around 70. in the direction of about 130. So it's a dip angle of 70 in the direction of 130. So I'll use that. 70 and 130, that's it. So I'm going to go for the extrude button. So that one says extrude lines or mesh surfaces. So I'm going to extrude it. I'm going to define the orientation. I'm going to dip it down by 30. No, was it 70? Sorry, 70 in the direction of 130. The distance it should extrude it by is 25 meters because my interlevel spacing was 25 meters. And after I extruded it, so what this will do, it will extrude it just down in the direction that you specified. But after I extruded it, I want to bring it back to the center. I want to bring it back to the middle. So as I center my extrusion, and because that 25 meters is not along the dip, it's the actual vertical distance. It's the vertical extraction distance. I check the second button as well because that will make the correction for the distance along the dip of that selection. So if I now say accept and I say I'll call it XXX7, what this should do is give me a tube for each one of the stopes. So let's see if I get what I want. So now I've got a tube for each one of these stopes. Now I can see I've got something that looks already quite useful. The only difference at the moment is all these tubes are open. They're not closed. So I want to close those tubes. So for that, I'll say repair the holes in a mesh object. So repair holes. And I'm going to choose an arbitrary large number, just 500. And I'll call this XXX8. And that will close up all my surfaces. Okay, so that closes up all my surfaces. So now I'm good. This should be something. The only thing to test for now is to see if the poly orientation is in the right direction. So I'm going to say backface culling, and you see I don't see any changes on the backface culling. So it seems like this file is good. So I can now save out this file and take it to Mat3D, and Mat3D should accept it as is. Or it could be a complex wireframes, and it should be fine as well. Just one word of caution. When you save something that goes into another software package, just ensure that binary and triangle strips, these two options are not selected. So if you want to make your file smaller and quicker to load in GEM4D, then you can tick those boxes because they make the file smaller and easier to load. But those options are not supported by many mine design packages, and it's not supported by Mat3D. So when you save something out for Mat3D or any other mine design package, just make sure the default is they are unchecked, and just make sure they're unchecked. Cool. Now I'm done with what I wanted to say. Any more questions? No one?
Nothing from me, Frans. That's been really good. Thanks.
Thanks, Jeff. But if there's no more questions, then I'll conclude the discussion. I thank you all for attending, and yep, I'll do it again in future, but I won't do it too frequently. But let's say I'll try to do it maybe once a month or once in 2 months for those that's got questions. It's just easier to accommodate the questions at once during a session like this than to answer some questions that could be quite involved to answer on paper. Thank you.